Hello students, good morning to all. In this lecture, we learn block diagram of 8085 microprocessor in detail. Okay, now we start. So I'm sharing the screen. See on your screen. See student, this is the block diagram of 8085 microprocessor. Okay, this diagram having number of blocks. See here in 8085 microprocessor, this block is accumulator. Accumulator. This register is a 8-bit register. Then another block. This is a temporary register. Temporary register. Then flag registers. Here flip-flop. You can say flip-flop also, flag register, also called as status register. Then this block is a ALU block. ALU unit, arithmetic logic unit. Okay. Now see the interrupt control block, serial IO control block, instruction register, instruction decoder, and machine cycle. See here, general purpose register also. These are the general purpose register, WZ, BC, DE, HL. These are the general purpose register. Then stack pointer, program counter, increment and decrement registers, here timing and control unit, address buffer, and data or address buffer. These are the functional blocks of 8085 microprocessor. We see in detail all these blocks. Okay. Now we see first block, that is arithmetic logic unit, ALU. ALU. This block, arithmetic logic unit. Yeah. Internal bus. Okay. The arithmetic logic unit is a 8-bit unit. This unit is a 8-bit unit. In this unit is perform arithmetic and logic as well as rotate operation. It consists of binary adder to perform addition and subtraction by 2's complement method. So we all are know about the result is typically stored in accumulator. See here. Previous lecture we also learned generic microprocessor block diagram. There is also see the accumulator. In accumulator, generally the result stored in accumulator. Okay. An accumulator, temporary register. See here, accumulator, temporary register, and status register or flag. You can say here flag, also called as flags or status register. Accumulator, temporary register, and flag register are closely associated with ALU. The temporary register, this temporary register is used to hold data during the arithmetic and logical operation. Okay, this temporary register hold the data during an arithmetic and logical operation. Okay, and flag register. This flag register is a set or reset according to the result. So the arithmetic logic unit ALU. This register is an 8-bit register. What is use of this register? This register is used to perform arithmetic, logic, and rotate operation. Arithmetic, logic and rotate operation. Okay. And in this unit, accumulator, temporal register, status register, these are closely associated with ALU. Okay. Now we see after that next block is a temporary register. Okay. Next block is a temporary register. This temporary register is a 8-bit register. 8-bit 8-bit register. It is the just see this register is a closely associated with ALU. Okay. So this temporary register hold one of the data. Which data? From memory or general purpose register during an arithmetic and logical operation. So temporary register hold the data. Okay. Hold the data during an arithmetic and logic operation. Okay. And simply you can say here temporary register store the temporary data at the time of execution. Okay. Temporary register store temporary data at the time of execution. Now, next register we see, next register is accumulator. Okay. This accumulator register is also 8-bit register. Okay. And this register is also associated with ALU. Okay. The accumulator is also called as A register. A register. This accumulator also called as A register. During the arithmetic logic operation, one of the operand is available in accumulator. Okay. The result of arithmetic logic operation is also stored in accumulator, or you can say process data stored in accumulator. When ALU perform arithmetic and logical operation, after the completing this process, result will store in accumulator. Okay. So simply you can say process data stored in accumulator, result stored in accumulator. Okay. After completing the arithmetical logical operation, result will store in accumulator. This accumulator register is an 8-bit register denoted by A. We also called as A register. Okay. Temporary register is also 8-bit register. Both are closely associated with ALU, arithmetic logic unit. Now, after that, we see next register, that is flag register. See here, flag register. We also called as a status register. This is the 8-bit register. This register is also 8-bit register. Okay. It is an 8-bit register. Is that status register. But only 5 bits are used in 8085. Only 5 bits are used in this flag register. The flag register of 8085, the flag are affected by the arithmetical and logical operation. Flag are affected after the arithmetic and logical operation in ALU. The flag register also called as a status register or condition code register. There are 5 flags. See which are these 5 flags. 5 flags. First flag is S, that is a sign flag. Okay. Next is a zero flag. Z denoted by Z. Zero flag. Third one is a AC, auxiliary carry flags. Auxiliary carry flag. After that, fourth is a parity flag, denoted by P. Parity flag. And fifth flag is a carry flag, denoted by CY. Carry flag. These are the 5 flags in 8085. Okay. Now we see one by one each flag. First, see the sign flag. Okay. Before that, again I will repeat this point. Just we see the ALU, temporary register accumulator. Okay. So the accumulator, sorry, ALU, arithmetic logic unit. This unit is a 8-bit unit. This unit is used to perform arithmetical and logical operation. Temporary register, accumulator, status register, these registers are closely associated with ALU. Okay. And temporary register, after that we see the block, next block, that is a temporary register. Temporary register store the temporary data at the time of execution. Okay. Or you can say hold the data. Okay. This register is a 8-bit register. After that we see the next block, that is accumulator. The accumulator is also 8-bit register, and this 8-bit register accumulator store the result. After processing arithmetic and logic unit, whenever addition is performed or subtraction is performed, after performing the arithmetical operation, result will store in accumulator. Okay, so process data stored in accumulator. Now we see the status register or flag register. Okay, also called as status register. In 8085, having 5 flags: sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Okay, we see one by one each flag. Okay, first started from sign flag. In the flag register, only 5 flags are active in 8085. See here. First sign flag, then zero flag, inactive, D5 bit, then auxiliary carry flag, D3 bit is inactive, then parity flag, and CY carry flag. Here, bit D0, D1, D2, D3, D4, D5, D6, D7. The 8-bit register, but only 5 bits are active in 8085 microprocessor. So this sign flag. Sign flag is a set 1. Sign flag set 1. If the bit of D7, see here, bit of D7 of the result in the accumulator is 1. Okay. यहाँ पे ये कौन से बिट है D0 to D7. साइन फ्लैग कब सेट होगा? If D7 bit is 1. For example, result 1 Okay, this is the 8 bit. So this is the MSB bit. That is a D7 bit. If this D7 bit is 1, okay, D7 of the result in the accumulator is 1. That time sign flag set to 1. If otherwise sign flag set to 0. अगर यहाँ पे D7 बिट 1 है तो ये क्या होगा, साइन फ्लैग सेट टू 1. अगर यहाँ पे D7 बिट 0 0 1 1 0 1 0 0 1, this is your result. D7 bit is 0. That time sign flag set to 0. This flag is set when the result is negative. कब सेट होगा ये साइन फ्लैग, जब रिजल्ट क्या होगा, नेगेटिव होगा. We all are studied in last year in 11th standard, okay, binary numbers. Okay, when MSB bit is 1, that time result will negative. So this flag or sign flag set when the result is negative. This flag is used only for the sign number. इसलिए यूज होता है ये flag only for the sign number. Okay, again I am repeating this sign flag. Sign flag is the set 1. Sign flag set 1 if the bit D7 of the result in the accumulator is 1. When the sign flag is set 1, if the bit D7 is bit D7 of the result in the accumulator is 1. Otherwise, it is 0. Otherwise, the sign flag set to 0. Okay. Now, next we see next flag, that is 0 flag. This 0 flag. Sign flag we also covered. Then next is a 0 flag. 0 flag is a set 1 if in the accumulator is 0. अगर रिजल्ट क्या होगा, 0 0 0 0 0 0 0. accumulator क्या होगा, 0 होगा. ओके, कब सेट होगा, जब accumulator क्या होगा, 0. that time 0 flag set to 1. ओके, अगर accumulator में 0 है, जो भी रिजल्ट है वो क्या होगा, 0 होगा. तभी क्या होगा, साइन फ्लैग 0 फ्लैग सेट होगा. अगर रिजल्ट नॉन 0 है, ओके, अगर एक्यूमुलेटर में 1 1 ये रिजल्ट है, नॉन 0 रिजल्ट है, तो क्या होगा, 0 फ्लैग सेट टू 0. इफ रिजल्ट इज 0, दैट टाइम 0 फ्लैग इज सेट. रिजल्ट 0 है तभी क्या होगा, 0 flag set होगा. Otherwise 0 flag will reset or z equals to 0. Okay, again I am repeating, 0 flag कब सेट होगा, जब क्या होगा, रिजल्ट 0 है, accumulator stored 0. Okay, otherwise it is reset or 0. Okay, now next is a auxiliary carry flag, AC, denoted by AC. Next one is auxiliary carry flag. Auxiliary carry flag is the set 1 if there is a carry from bit position D3 of the result in the accumulator. Otherwise, reset. Okay. Auxiliary carry flag कब set होगा, if carry from bit D3. अगर D3 से कोई भी कैरी जनरेट होता है तो क्या होगा, ऑक्सिलरी कैरी फ्लैग सेट होगा. सी द एग्जांपल, here this is the example 1 1 0 1 1 1 1 1, 0, 0, 0, 1, 1, 1, 1, 1. अभी addition is performed. Bit 0, 1, 2, 3, 4, 5, 6, 7. Okay. 1, 1. All of you know about the addition rules of addition in binary. Okay. So 1, 1, 0, carry 1, 1, 1, 0, plus 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Here, carry is generated from this D3 bit. Here in this addition, carry is generated from this D3 bit. Carry is 1, 1, 1, 1. Carry 1, 1, 0, 0, 1, 1, 1. So in this example, carry is generated from D3 bit. That time auxiliary carry flag set to 1. That time auxiliary carry flag set to 1. Otherwise 0. अगर यहाँ पे 0 होता 0 0 1 1 1 carry 1 1 here. No any carry generated from D3 bit. That time auxiliary carry flag is reset. If carry is generated from D3 bit, that time auxiliary carry flag is set, otherwise reset. This flag is used for BCD operation. Okay. Now next flag is a parity flag. Next flag is a parity flag denoted by P. Parity flag is set 1. If result in accumulator has even number. Accumulator में क्या store होगा? Even number. Even number of ones. You can count even number of ones. Otherwise, it is reset. For example, अगर आपके accumulator में result store है 1 0 1 0 1 0 0 1. Okay. So count the ones 1 2 3 4. Okay. 4 ones present in this number. So parity flag set to 1. अगर यहाँ पे 0 होता, यहाँ पे कितने ones है? 3. If in your accumulator result contain only 3 ones, 3 is an odd number. If result contain even number of ones, accumulator has even number of ones, that time parity flag to set. Okay, and simply if your result is a even parity, that time parity flag set to 1, otherwise reset. Okay, this is about the parity flag. Now last flag, that is carry flag. Carry flag. Carry flag is a set if result of arithmetic operation result in a carry from bit D7. अगर after D7 carry generate होता है तो क्या होगा? Carry flag set होगा. कौन से bit? After D7 bit. Here, this is after the D7 bit. Okay. For example, 0 1 0 1 0 0 0. यहाँ पे हम एडिशन परफॉर्म कर रहे हैं 1 1 0 0 0 0 0 0. Okay, what will be the result? See here 0 0 0 0 1 0 1 1 1 0 0 is plus here carry 1 1 1 0 1 1 1 One is result, one is carry. After D7 bit carry is generated, that time carry flag is set. Okay. When after the D7 bit carry is generated. Okay. When the carry flag is set, if the result of arithmetic operation result in a carry from bit position D7. Otherwise, it is a reset. This flag is also used to indicate borrow condition during the subtraction. Okay. This flag is also used to indicate the borrow condition during the subtraction operation. This is about the flags in XII. Your board exam. On the flag, ask in your board exam for 3 marks. Okay. In 8085, there are 5 active flags: sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Again, I am repeating. Sign flag कब set होगा? If D7 bit is 1, that time sign flag set to 1, otherwise 0. Zero flag. If accumulator contains 0 or result is 0, that time 0 flag set, otherwise reset. Auxiliary carry flag, when D3 to D4 bit carry is generated, that time auxiliary carry flag is set, otherwise reset. Then parity flag, if your result is even parity, that time parity flag is set, otherwise reset. Then carry flag, after D7 bit carry is generated or carry from bit position D7, that time carry flag set, otherwise reset. Okay. Now after that we see the next block, that is instruction register. Instruction register. When the instruction is a fetch from memory, it is stored in instruction register. It is a 8-bit register. Instruction register is a 8-bit register. This register cannot used in programs. Okay. When instruction is a fetch from memory, it is stored in instruction register. Okay, so it is stored in instruction register. Okay. This is 8-bit register. Next block, that is instruction decoder. This unit decode the instruction. Instruction decoder. This instruction decoder, this unit decode the instruction stored in instruction register. Instruction register में जो भी इंस्ट्रक्शन है उसे डिकोड करने के लिए कहाँ पर स्टोर होगा? इंस्ट्रक्शन डिकोडर में. ओके, दिस यूनिट डिकोड द इंस्ट्रक्शन. कौन से इंस्ट्रक्शन डिकोड करेगा? जो स्टोर है, कहाँ पे स्टोर है? इंस्ट्रक्शन रजिस्टर में स्टोर है. सो दिस यूनिट डिकोड द इंस्ट्रक्शन. Decode the instruction. Which instruction? those instructions stored in instruction register. Okay, stored in the instruction register. Okay. It determines the nature of instruction. Okay. Now, after that, we see the next block, that is the general purpose register. We are see in your block diagram. Okay, you can take a screenshot of this block diagram and see in this block diagram accumulator status B register B, C, D, E, H, and these are the general purpose register. Okay, after that stack pointer, program counter. Now you see the general purpose register. There are 6 8-bit general purpose registers, namely B, C, D, E, H, L register. Okay, B, C, D, E, and H, L. General purpose register. General purpose register. There are 6 8-bit general purpose register. 6 general purpose register. 6 general purpose register. All these general purpose register are 8-bit register. That is a B, C, D, E, H, L. These are the general purpose register. These registers are 8-bit. B register is 8-bit, 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 8. There are 6 8-bit general purpose register. Okay, here namely B, C, D, E, H, and L. B and C, this register B and C register are combined together as BC register pair, BC register pair for 16-bit. For 16-bit. Okay. Individually, B is 8-bit register, C is also 8-bit register. अगर इन्हें हम combine करते हैं as a use करते हैं combined as a register pair, तो कितने bit का use करेंगे हम 16-bit. Okay, 16-bit operation. Similarly, D, E register can be used as a D register pair, and H and L register pair also. This HL register pair is also used as a memory pointer. This HL register pair used as a memory pointer. Or you can say here M register for storing 16-bit address in some instruction in 8085. Okay, and so I'm again repeat general purpose register in 8085. There are 6 8-bit general purpose register, namely B, C, D, E, H, L. इन्हें हम individual use करते हैं तो these register are 8-bit. अगर combined use करते हैं as a register pair तो कितने bit का होगा 60-bit का. So BC register pair is 16-bit. DE register pair is 16-bit. Also HL register pair is a 16-bit. But individually B register is a 8-bit register. Okay. इन्हें हम individually use करते हैं तो वो register कितने bit का होगा 8-bit का होगा. अगर इन्हें combinedly हम use करते हैं So this register pair is a 16-bit register. And lastly, HL register pair. The HL register pair is also used as a memory pointer for storing 16-bit address in some instruction in 8085. Okay. Now, this I hope you can understand this block, that is general purpose register. Now we see next block, that is stack pointer. Stack pointer. Stack pointer. Denoted by SP. SP. The stack pointer is a position of memory used as a LIFO. That is a first in, last out. This is a mainly used during the subroutine operation. Stack pointer is a 16-bit register. See here, this register is a 16-bit register used as a memory pointer. इसे use होगा ये, used as a memory pointer for denoting the stack position in memory. The stack pointer is decremented each time. Stack pointer is decremented each time when data is loaded into the stack, and incremented when data is retrieved from stack. Stack pointer always point to the top of stack memory. Okay, the stack pointer always point to the top of stack memory. The stack pointer is a special purpose register. Stack pointer is a special purpose address pointer. Stack pointer and program counter both are the special purpose register. We can say here stack pointer is point out the memory. Okay. And stack pointer always point to the top of stack memory. Point to the top of stack memory. Top of stack memory. Okay. This is our stack pointer. Stack pointer decrement कब होगा? When stack pointer is decrement each time when data is loaded into stack. जब data load होगा stack में तब क्या होगा? Decrement होगा, and increment when data is retrieved from the stack. Okay. So stack pointer always point to the top of stack memory. Now we see next block, that is program counter. See the program counter, that PC denoted by PC. The program counter is a 60-bit register. It's used to point the address of next instruction. Really use to point the address of next instruction. Address of next instruction to be fetched from memory. Address of next instruction to be fetched from memory. Recently, program counter stored the address of next executable instruction. Okay. What is the program counter? Program counter is a 16-bit register. It is a special purpose register. It is used to point the address of next instruction to be fetched from memory. And simply you can say here, program counter store the address of next executable instruction. When the instruction is fetched from memory, program counter automatically incremented. Here, when instruction fetched from memory, program counter automatically incremented to point out the next instruction. Increment होगा point out the next instruction. Okay, got it? Program counter. Okay, now we move on our next block, that is increment and decrementer. So incrementer and decrementer. Incrementer or decrementer. Decrementer. This unit is used to increment or decrement the content of 16-bit register. Okay, simply incrementer or decrementer. This unit is used to increment or decrement the content of 16-bit register. Okay, used to increment or decrement the content of 16-bit register. What is the use of incrementer and decrementer unit? This unit is used to increment or decrement the content of 16-bit register. Okay. Now next point, that is timing and control unit. Bottom side is very important block or unit for our microprocessor. It is the internal clock generator is available in this unit. This unit has a microprogram for all the instruction to carry out the micro step required in completing the instruction. This unit receives the signal from instruction decoder. Okay. Firstly, I'm sharing the screen. See on your screen. See students, see here. This is the timing and control unit. You already see accumulator, temporary register flag, ALU, instruction register, instruction decoder, general purpose register, BC, DE, HL, stack pointer, point out the stack memory, top of this stack memory, program counter. Okay, it stored the next address of next executable instruction, address of next executable instruction stored in program counter, incrementer and decrementer. Okay, after that we see the timing and control unit. Okay, this unit. This timing and control unit, the clock generator is available in this unit. This unit has a microprogram for all the instruction to carry out the micro steps. This unit receive the signal. From instruction decoder. From instruction decoder and machine cycle. Instruction decoder and encoding unit, instruction decoder and machine cycle. Okay. And encoding unit and generator control signal according to the micro program for the instruction. So the control unit, this unit is used to control the whole circuitry. So the clock generator is available in this unit. This unit has a micro program for all the instruction to carry out the micro step required completing the instruction. So this unit is a control whole circuitry, right? Control unit. Okay. So this is about the complete block diagram or internal block diagram of 8085. Okay. I'm again sharing you a block diagram. So see carefully, students. See this diagram. Okay. Accumulator, temporary register. This block flag, status register, ALU, arithmetic logic unit, then instruction register, instruction decoder, general purpose register, that is BCD, HL. These are the 8-bit register. When we use combinedly this PC register pair is a 16-bit register, stack pointer, point out the stack, top of stack memory, program counter, store the next executable, address of next executable instruction, incremental or decremental. Okay, then timing and control unit. This unit, see here, internal clock generator, CLK. See here, internal clock generator is available in this unit. This unit has a micro program for all the instruction to carry the micro steps requiring completing the instruction. This unit receive the signals. Here, this unit receive the signal from instruction decoder and machine cycle encoding unit and generate the control signal according to the micro program for the instruction. Okay, this is the address buffer A8 to A15, where we will learn in pin diagram or address or data or address buffer AD0 to AD7. Address bus is connected. See here, top of this diagram, serial IO control, SID and SOD. This is the internal data bus. Here, this block is an interrupt control. This interrupt control connect the interrupt pins, hardware interrupt pins, that is INTR, INTE, RST 5.5, 6.5, 7.5 and trap. Okay, I hope understand, students. Okay. Okay, this is about the internal block diagram of 8085 microprocessor. Okay, thank you, students.